In this video, we want to start looking at section 1.3, data collection. So first I'll mention once again your strange stat, top of the paper. 30% of all people can flare their nostrils. And if you're able to do that, you probably know what that means. If you don't know what that means you probably can't do it. I'll let you sit here and try while people are looking at you. So we want to talk about ways of producing or collecting data. So we want to get through just the first part of these notes, and then we're going to do kind of a lab using the calculator. So eventually here, you're going to want to, if you want to pause the video and go grab a calculator from the counter, you're going to need that later in the video. If not, you'll have to pause that later because we're going to show you how to do something on the calculator, and then we're going to do that for you to kind of produce and create your own data to collect. So let's talk about methods for producing data. The first way is by sampling. And this is drawing a subset from the population. Now, as we talked about, the population is everybody of interest. And then a sample is just some subset. So one way of producing data is sampling or getting a smaller group of people that you're going to collect your data from. Another way of collecting data is doing an experiment. So an experiment, think of what you did in science, right? Where you change the temperature of something and then you record what happens. Or if you're using a slingshot, you pull it back a certain distance, let it go, see what happens. Pull it back a little bit further, let it go, see what happens. Pull it back even further, let it go. So you are imposing a change and then measuring the results. You know what that change is, and then you're able to measure what the results of that change are. Next is a simulation. And this is just a way of reproducing something in the real world that maybe is easier than doing it for real. I'm going to do an example here and explain that one out in more detail. So I'll come back to that one, doing a simulation. And then we have a census. A census is using a measurement from every single person in the population. In the United States, they do a census every 10 years, where they try to count how many people they are in the country. That's the idea. A lot of statistics can go into doing that, especially if you want a census as you're trying to measure from everybody. Many times that's very expensive and intensive, so they don't do that. And then finally, you can do a survey. Just asking questions. You take that sample and you go around and you ask people various questions to get your data and your results. So we have a couple types of samples we want to talk about. First is a random sample. A random sample is every individual of a population is equally likely to be chosen and included in a sample. Now there's a lot of different ways you can do this. The simplest way is you can think, well, throw all the names in a hat and then pull a name out of a hat. So imagine we wanted to choose 5 seniors. And we put all the seniors' names into a hat and we drew out 5 names. That's a random chance. Everybody has an equal chance of being selected. That's a random sample. However, there is a higher level that we can do, which is known as a simple random sample. And this can get complicated, and we'll try to explain more in class. But let me just say it this way. Now imagine if we wanted to choose 5 seniors, and instead of putting all the names in a hat, we randomly chose 1 senior out of each win room. So in my senior win room, I have seniors, and we chose 1 person out of that win room. And then we went to Mrs. Dillon's win room and we chose 1 person out of her win room and so forth. Now, if we did it that way, that would still be random, but that would not be simple random. And the reason that would not be simple random is I could not choose 2 students out of my class. I'm only going to get 1. Still random, but if it's a truly random sample or simple random sample, we would want every possible combination. And it's possible if we put all the seniors' names in a hat, I may get 2 or 3 people out of my win. So that's how the difference is. We will get into that detail much more in the future because it can be kind of hard. So what is not a random sample? Asking for volunteers. Hey, who wants to ask my survey? Who wants to vote online for who to kick off the island or who should continue to be singing or whatever reality show you want to be. That is not a random sample. That's just people that care enough are going to respond. Okay? And then choosing by some the first 5 people in, the last 5 people out, right? All those things may have things special about those people. Okay? We'll talk more about that as we go also. So random sampling, and this is what we want to look at today, is idea of drawing names from a hat. That's one I just mentioned earlier. Now, that's hard to get all the names in a hat and try to draw them all out. So we want to have better ways of doing that. And one way to do that is to use random numbers. Now, in the past, random numbers were done with a random number table. We're going back in history here. It was hard to get random numbers not using computers or calculators, right? So one way they could do it is you could have a 10-sided die, has the numbers 0 to 9, and you just roll it a whole bunch of times. And every time you roll it, you write down a digit. And so you get this kind of random number table. Just a list of random numbers. Now, how could you use this? And that goes back to our earlier thing of simulation. Let's say you want to simulate flipping a coin 10 times. Now, you could flip it 10 times, but let's say you want to simulate 100 times or 1,000 times or something like that, right? You don't actually want to flip the coin. But because heads and tails is 50-50, you could say, well, heads is an even number, tails is an odd number, and then if we looked at the first 10 digits here on this random number table, the odds are tails, so we would have 1, 2, 3, 4, 5 tails, and then we would have 1, 2, 3, 4, 5 heads. Now, not everyone. Let's pick another, a different color here. Let's pick another, let's look down here. How many heads and tails would they have here? We have 1, 2, 3, 4, 5, 6, 7, 8 heads, and then only 2 tails. So you can see by using this random number table, you can simulate flipping a coin multiple times. And you can do this over and over again. And it's much easier and quicker than just actually flipping a coin. But the probability in percentages, heads and tails, 50-50, odds are even, 50-50, is exactly the same. Now, we can also do this by using a random number generator. And you can find these online, but we are going to do this with our calculator. So let's talk about how we can do this on the TI-83. Okay? So if you have a TI-83 or 84 or 84 plus color or whatever you have over there, we are going to go through these steps to show you how to do that. So if you go to the calculator, and let me bring up my calculator here. So if you have your calculator, you are going to hit the math button, and if you have not seen this before, if you look at my screen, you can see where the red button is, so you know what key I pushed as I went across here or what I'm doing on the calculator. And we are going to go all the way over to probability, which is the 1, 2, 3, 4th number over. Now, first you'll see right at the top, R-A-N-D, random. So if we just hit that, let me show you what that does. If we hit random, it puts it on this screen, and every time we hit enter, we get a random number. Now, the problem with these random numbers, as I continue to hit enter, is this only gives you random numbers between 0 and 1. It gives you decimals. Those are not as useful. So we don't really want to use random. Instead, we are going to go to math, go over to probability, and we're going to go down to random integer. And if we go down here to random integer and hit enter, it's going to ask us some questions. It's going to ask you some lower, the upper, n, which is how many, and then you paste that in. So let's say we want to only pick 2 numbers. We want to pick 0 and 1. And let's say we want to pick 10 of them. So let me hit paste and you'll see what it looks. Now, some of you, depending on your calculator, you may see this screen. It may go straight to random integer, and you have to put in 0 for the lower, 1 for the upper, and 10 for the numbers. So when I hit enter, notice what happens. It randomly generated 10 0 or 1s. Now think about my coin flipping example a second ago. If we said 0 is heads, 1 is tails, this is 6 heads, 1 tail. If I hit enter again, there's another 10. And that time I have 6 tails and 4 heads. So every time you hit enter, you randomly generate basically 10 coin flips. Now, but when we go back to our math, probability in our random integer, we can change these numbers. Let's say I go from 1 to 100 and I say 2. $102. Think about, if I get ready to hit enter, what is this going to do? This is going to randomly pick numbers from 1 to 100. And then how many numbers is it going to pick? It's going to pick 2. And every time I hit enter, I get 2 more random numbers from 1 to 100. So you can see how we can use this to randomly generate numbers. We can then use this to randomly simulate something that's easier than actually doing it for real. So for example, let's say we wanted to simulate rolling a die. Your standard 6-sided die. We could go to probability, random integer, 1 to 6, and if I said 1, that would be rolling 1 die. Now, if we go back to random integer, and let's say we change this to 2, now we would be rolling 2 dice. And you can see how we're able to do that. So we can simulate situations where our calculator can help us randomize numbers that we can use. Now, what we want to do here for the rest of this is we want to do a simulation of something called the birthday problem or the birthday paradox. So you should have a second sheet of paper where it asks this question. Suppose there are 25 people in a class, 25 people in the same room as your paper says. What is the probability that any 2 of them share the same birthday? So if you imagine being in this room and imagine there's 25 people in this class, what is the probability that 2 people share the exact same birthday? That's what we want to figure out. Now, that can be hard to do to calculate exactly using math and probability and numbers. So instead, we are going to do this by doing a simulation and letting our calculator do this for us. Okay? So, we're going to use a simulation to help us solve this problem. So, if you look at the other piece of paper, you'll see this. And this shows you the steps that you want to go through. So if you follow this paper and actually see what I'm going to do, we're going to go through this. So to get started, we're going to go back to our math, random probability, 1 to 365. So what that is doing is we are randomly picking a number between 1 and 365. That would be randomly picking a birthday. Or just imagine every day of the year is numbered. January 1st is 1, December 31st is 365. We're going to ignore leap year here for today. And this way we can easily randomize something. So, February 1st would be 32. January's got 31 days. So we're just numbering all the days of the year. And then we want to select 25. So what we are doing is we are selecting 25 birthdays out of the year. And we want to determine how many repeats. Now, as you look at this list, you can scroll across to try to see all the numbers. Now, this is really hard to remember even what you've already seen to know if you have any repeats. So we don't want to do that. So we're going to add a couple things. So once again, I'm going to go through this in the video that you can see. This is also written down in your paper so you can see how we're going to do this. So let's go back. See here. So we're going to go to math, random integer. We're going to do 1, 365, 25. We're going to hit enter. Now, look at number 1. Before we do anything, we're going to do the arrow, which is store. You can see the red button on my screen. And then we're going to do L1. And you can see L1 is down here at number 1, but it's blue, so I have to hit second, that button, number 1, to get L1. And then I hit enter. And we don't look like we're much better off than we were before. However, if you hit the stat button, this is part of why we're doing this today, to learn how these buttons in the calculator work. If you hit stat edit, you can see all of our numbers are listed there. So now we could scroll down and look at them that way also, okay? But that still is hard to keep track. So the second thing we're going to do is once we have done this, your number 2 is you're going to do sort L1. So I'm going to go back to the stat button. I am going to go down to sort. And then I'm going to go back and say L1 again. So I hit second, number 1, and hit enter. And it says done. Great. But what did we just do? Go back to stat, go back to edit, and now it has put all of our numbers in order. It's sorted our numbers. So now we can easily just scroll down and see, do we have any repeats? And you can see, yes, we've already have right here, 48, 148, 148. That is a repeat. We also, I skipped over one already. We had 82 and 82 repeats. So you scroll through here. Once you find a repeat, you can stop. You don't have to keep looking. Now, the second part is you want to keep track of these. So if you go to this paper, you can see we just did trial 1. If you followed me, I just did this and did I have a repeat? Yes. I don't care if you had 1 repeat. I don't care if you had 2 repeats. How many repeats did you have? Now, if you went through your list and there were no numbers that repeated, you would select no. Mine was yes. Do this on your own. Now, once you've done that, you now go back to here and you repeat it and you go back to number 1. So I go back to math, probability. Some of this will already be typed in for you now. Random integer, oops, hit the wrong button. Random integer, 1, 365, 25. Hit enter. Store, alpha 1. Then I'm going to hit stat, sort A, second L1, hit enter, so it's done. Now I go back to stat, edit, and I'm going to go through my list and see, do I have any repeats? And I can see already I have 88 and 88. I don't even care about the rest of the list now. So I can go back here and I can say number 2 is also yes. So you want to repeat this 10 times. If you need to pause, go back through the video and just follow along on how to do each of those buttons. That's fine. So you want to repeat this trial 10 times and then figure out what percent of your trials had repeats. So there's 10 of them, so count out how many yeses, and that number divided by 10 is your percentage. Later, the second question, we're going to combine all the classes together and see what is our